In this example, we're going to continue talking about topic 10.8, and we are going to look at example 2. So again, I'm going to start the ratio test by plugging in n plus 1 anytime I see an n. So I have the limit as n approaches infinity, the absolute value of n plus 1 squared times 2 to the n plus 1 over 3 to the n plus 1. And then I'm going to multiply by the reciprocal of the original. So 3 to the n over n squared times 2 to the n plus 1. So I am going to separate that a little bit. So the limit as n approaches infinity of n plus 1 squared times, remember when we are adding, to undo this, we are multiplying our bases, because remember when we multiply, we add our exponents. I'm just taking that apart. And then I'm doing the same thing here, 3 to the n times 3 to the first times 3 to the n over n squared times 2 to the n plus 1. And I didn't take the 2 to the n plus 1 apart because I knew it was going to cancel. So I know that 2 to the n plus 1 cancels, 3 to the n cancels, and that's it. So now let's write out what's left. So we've got the limit as n approaches infinity of 2 times n plus 1 squared over 3n squared. And then I know that my limit as I approach infinity is, because the exponents are going to be the same. Even if I FOILed this out, I know my highest exponent is a squared. So I know that that value is 2/3. So this is equal to 2/3, which is less than 1. So remember, less than 1 means that I'm going to converge by the ratio test. So therefore converges by the ratio test.